Okay, going over to question 4. Why can we always solve the problem with square excess? Well, that's the same thing as finding x such that x plus little a times x equals big A, where we want everything to be positive. Okay, so if we look at the corresponding quadratic equation, we get x squared plus little ax minus big A equals 0. And so then we can just use the quadratic formula. So we see the discriminant is always going to be positive. And furthermore, we see that a squared plus 4a is always going to be bigger than a squared. So square root of that is always going to be bigger than a. So in the numerator there, minus a plus square root of a squared plus 4a is always going to be positive. So there always is a positive solution. Whereas if we look at the case with square defect, that's the same thing as solving a minus x times x equals big A. And now we've got a problem, right? Because well, if we look at the corresponding quadratic formula, we see that the signs flip now. So we've got a plus or minus square root of a squared minus 4 big A, and we can see straight away that we're going to be in problem if that discriminant is negative. Okay, if it's not negative, then there's always going to be a positive solution. In fact, there's going to be 2 positive solutions. But we need little a squared to be bigger than 4 times big A. Okay. Okay, and the final question is, how can we always put a circle around a triangle? How can we always find this circle circumscribing a triangle? Well, one thing that we know about circles is that if you have a chord on a circle, then the perpendicular bisector of those chords is going to be a diameter, right? And so for the triangle to be circumscribed within the circle, we need the sides of the triangle always to be chords. So all we have to do is draw a perpendicular bisector of any side. Okay, and so in this situation here, we just go zhunk, zhunk, and maybe we also go zhunk. We can do it for all 3, but we only need it for 2, right? Because where the 2 diameters meet, that's going to be the center of your circle. And then all you've got to do is get out your trusty compass, put it on O, put on the moving part at A, and it's going to go through A, B, and C. And there is your circle.